Hello everyone. In this playlist, we'll be building end-to-end data engineering project using AWS Cloud. So the project is named as Spotify Data Engineering End-to-End Project. The architecture of the project is shown here. The data will be present in our staging layer. Then we'll be using AWS Glue to build our ETL pipeline that will take a data from a staging layer and transfer into our data warehouse. Once our data warehouse is in place, we'll be running a glue crawler that will create a database and populate a table for our database. Then we'll be using AWS Athena to query a data present in a table. Once everything is set up, we can use AWS QuickSight to do a visualization and to gain a business insight out of our data. The dataset that we'll be using in this project is Spotify dataset 2023. The dataset consists of 5 CSV files: albums, artist, Spotify data, Spotify features, and Spotify tracks. Spotify albums consist of details of all the albums, tracks, artist, and the release date of the album. Spotify artists consist of details of the artist, name, number of followers, and the genre they sing in. Spotify data consists of album ID, album name, album popularity, artist. Spotify features consist of danceability, energy, loudness, mode, pitchiness, liveliness, and valence of the music. The tracks consist of track ID, track popularity, and explicit. You can view the description of the dataset from this link. I'll be attaching this link in the description of the video. The data is in raw format, so lots of pre-processing will be required. For this playlist, I have already pre-processed the data and I will be providing the dataset in the link in the description. I pre-processed the 5 CSV files and built 3 CSV files out of it, which is albums, artists, and tracks. I'll be providing these links in the description. So let's get started and start building this architecture. Thank you. Hello everyone. Let's start our project. In this video, we'll be creating an IAM user. We will be logging into AWS, then we'll be creating IAM user, and then we'll be assigning a relevant role to the user. So let's get started. To go to AWS console, let's just type AWS console. Let's go to the first link. Since we have already created the account, we can go and click on sign into the console. As of now, we don't have any IAM user, so let's log in into a root user and create our IAM user. So go to next and provide a password. We should not be using our root user for the project because root users may have lots of permissions and any misuse may lead to a bigger problem. So we should be providing a fine-grained access to the users who will be doing the project. So as of now, let's go to IAM. So IAM is a service that is used to give access to the user. So let's create a user. So I can create a user as PROJ. Since we need access to the AWS console, so I can just go and click here. I want to create an IAM user, so I need to tick here. I can provide a custom password as of now. We need to change the password in a later section, hence I'm just showing it as of now. I can just go and click next. So now we need to attach necessary permissions to our user. For this project, we are using S3 bucket, we are using AWS Glue, we are using Athena and QuickSight. So I'll be providing access to these all services for this user. I'll be providing Amazon S3 full access, but for a real world project, we can also fine grain this and provide access like Amazon S3 read only access, Amazon S3 create bucket access. Similarly, I will be providing AWS Glue full access, Amazon Athena full access, and Amazon QuickSight Athena access. So after all the access is selected, I can just see the permission boundary as well. As for this project, we don't need to set a permission boundary, so I can just go and click next. So these are the access that we are providing for this project. Now I can create a user. Now for this project, I'll be signing in as this user. So I can just go into this, I can just copy this link. Now I can sign out from the root user account. I can paste this link. I can provide a user ID and I am prompted to change the password. Now our password is changed. Now I can see I can logged in as a IAM user and I have access to S3. See, now if I go to any other service, I can see that access denied. When I go to CloudWatch, so I can log in into AWS services like this. So we have already provided necessary permission required for this project. So from next video, we'll be starting to create our bucket. Thank you. Hello everyone. In this video, we'll be creating our S3 bucket and we'll be creating a staging and data lake bucket, and we'll be adding a required data into our bucket. So we can see that we have S3 staging and S3 data warehouse. So we'll be creating a S3 bucket and we'll be creating a folder named staging and we'll be creating a folder named data warehouse. And we can add our data that is provided in the description in the S3 staging. Then we'll be creating a AWS data pipeline and we'll be transferring a data from S3 staging to a data warehouse after doing required transformations. Let's go ahead and create a S3 bucket. For that, let's first go ahead in AWS console. We can go in services and we can go and search for storage. We can go to S3. Let's create a bucket. A bucket name should be unique, so let's just write project date with data. let's leave as it is and let's go and create bucket. Once our bucket is created, let's create two folders named staging and data warehouse. Our staging layer is created. Now let's create one more folder named data warehouse. Now we can see that both of our layers are created. In real time, data in a staging layer will be coming through DynamoDB or our database instance. But for this project, we are not making use of DynamoDB or database, hence we are adding our data manually. So let's upload the data. We need to upload 3 CSV files that are albums, artists, and tracks. I can go and click open. I can just go and click upload now. Now I can go and click close. Now I can see that all the 3 datasets are available in staging. So in our next video, we'll be creating AWS Glue data pipeline to move our data from staging layer to data warehouse. We'll be doing a necessary joins and necessary data transformation and moving our data from staging to data warehouse layer. Thank you. Hello everyone. In this video, we'll be trying to create a data pipeline that will transfer our data from staging layer to data warehouse. We'll be making use of the AWS Glue to create a data pipeline. AWS Glue is a managed service provided by AWS to create a data pipeline. So this is our architecture that we need to implement. So in this video, we'll be implementing this part of our architecture. So we have data in staging layer. The data has come from different transactional DB. As of now, we have just uploaded data into staging layer, but in real time, the data will be coming from different places into the staging layer. After that, we'll be making use of the Glue ETL that will help us to transform and transfer the data from staging layer to data warehouse. So we'll be creating this pipeline that will help us to take three data from our source bucket and transfer it into a destination bucket. So these are the transformation that we'll be doing before transporting it into a destination bucket. So let's get started and build the project. For that, let's go and search Glue. Glue have made very easy for us to implement a data pipeline. Glue have created something called Visual ETL that will help us to generate a PySpark code visually using AWS service. So now I can visually drag and drop the source and destination bucket and all the transformation that are required to be done. Our source can be anything like AWS Glue Catalog, Kinesis, Kafka or PostgreSQL. As of now, our source is AWS S3. So we have 3 sources, one is track, one is album and one is artist. Let's drag 3 times. Now let's make this as artist and I can browse. This is for artist. Now we know the file format is CSV. Once we provide a correct file format and correct path, I can see it have turned into green. Now let's go and do for album. Now let's go and do for tracks. Let's provide the path. Let's provide the format as CSV. Now we can see that all the three sources are marked green. Now the next step is to join album and artist. Now I need to add transform and join. We need to join album and artist. We can clearly see how much easy it have made for us. And we can add the condition as artist ID and ID. Album and artist. Now we need to join track and this joined. The condition is track ID. Now next step is to drop all the unnecessary column. We can go and select drop field. Now we can see all the fields that are there. We know that this track ID is coming 2 times, so I can drop 1. And this ID and artist ID is again an inner join, so I can drop 1 ID. So all the other things can be kept as it is. Now next step is to put it into a destination bucket. Now there's a source and there's a target. Our target can also be anything from PostgreSQL, Teradata, MySQL, Google BigQuery, S3. So as of now, we are working with S3. So now in S3, so the format that we want to save is Parquet, and further we can compress our data for the faster query and for the lower storage. So let's take as Snappy and let's make our target as data warehouse. Now our pipeline is ready. I can run this as now we can go and click on script. We can see that it have automatically populated for us the AWS script. This is written in PySpark, so we can easily read from here what it is doing. It is going and fetching a data from that is artist.csv, and this node is doing fetching a data as albums.csv, and this is fetching tracks.csv. Now what it is next doing, it is joining on artist ID and ID these 2 frames, that is albums and artist. Next we are joining the output with the track. and whatever is a joint, we are dropping track ID and ID, and it is now saved into a data warehouse. So that is our overall job. In our next video, we'll be running and monitoring this data pipeline. Thank you. Hello everyone. In our last video, we have created the AWS Glue data pipeline. Now in this video, we'll try to run that. So in our last video, we have created a Glue data pipeline that will transfer our data from staging layer to data warehouse. Now it's a time to finally run the data pipeline and monitor that. To run a data pipeline, our AWS Glue service needs an access to run or to access the data that is present in S3 bucket. So we need to provide our Glue S3 access. So now let's go to AWS console and let's save it. And there is no run option, and we are seeing one error in job details. Let's go and see. There is no IAM role that is attached. So as of now, there is no IAM role available. So we need to attach the appropriate IAM role with S3 access to the AWS Glue. Since we don't have access to create an IAM role, we need to go back to our root account and create an IAM role that allows AWS Glue to access S3 bucket. So now let's go to our root account. So this is our root account. We can go to IAM and we can go to roles and we can create a role. And we need a role for this same account AWS service, and service that needs the role is a Glue. We can go on next, and the role that we need is S3 full access. Now we can attach this role and we can go to next, and we can provide an appropriate role name, that is Glue access S3. Now I can create role. Now this role is successfully created. Now let's go back to our root, to our IAM user. Now if I hit refresh, now I can see the Glue access S3 role. Now we need to provide resources to run this job. We are making use of Spark, and the Glue version that we are using is Glue 4.0, and Python version is Python 3. The worker type is, there are two types of worker, that is G1X and G2X. G1X have 4 vCPU and 16 GB RAM, and G2X have 8 vCPU and 32 GB RAM. And the number of requested worker is 10. Since our data load is very less, we can assign it to 5. And number of retries is 0. Like if a job fails, how many times it should retry before it fails. And timeout is 2880 minutes. That is too high, but it's okay for this job. Now we can save this. Now I can hit run. Now once it starts running, we can see that we can monitor our job. Now we can just go on view details. See. Now we can see the metrics when job is running. Since this metric is not populated because we have just started the job. We can just see the output logs as well. Since we have not created any logs or printed anything, so we may not have lots of logs, but yeah. Since this user does not have appropriate permission to view from CloudWatch, we are getting this error. So now we are slowly starting to see few metrics. Now this job is still running. You can view all these details and analyze it. Still our matrix is not visible since our data size is very low. Our matrix may not be visible much, but yeah. It is gonna take some time, so I'll continue this video after some time. Now we can see that our job have run successfully and we have seen the success data is 1. Now let's go to the S3 bucket and check the output. Now we need to go to data warehouse and we can see that it have created 16 Parquet file and this is the output that we are required. And the format of the data is Parquet. And we can see that each blocks are equally distributed, that is data is distributed across all the blocks, that is 3.3 MB each. That's all for this video. In the next video we'll be making use of AWS Athena to query the data. Thank you. Hello everyone. In this video we'll be creating a glue crawler and we'll be creating a data catalog, databases and tables using a glue crawler. A crawler creates a metadata that allows Glue and services such as Athena to view S3 information as a database with tables. That is, it allows you to create Glue catalog. This way, you can see the information that is present in S3 bucket as a database and a tables. So whatever data we have in our S3 bucket, now we can query them using normal SQL query if we are running crawler above that database. So let's go ahead and run a crawler. First of all, let's go to S3. Our data is present in data warehouse. So what do we need to do? Now let's go to AWS Glue and we can see there is a data catalog present here. So as of now there is no databases, there is no tables. So now let's go to crawlers. We can create our crawler. Now let's say our crawler name is NDL underscore. Now we can go to next. We have to add a data source. So we already know the data source, that is our data warehouse. Now I can choose. Now crawl solves subfolder. Now this is added. Now we can just go to next. Now we have to create a IAM role. So we already know that this IAM role gives Glue to access S3. So we can use the same IAM role. Now we can go to next. Now we can see that we have not created any database as of now. So we can go to Glue again and create a database. Let's create a database name Spotify. Now since our database is created, when you refresh, we can find this Spotify. Now we have to give a prefix to our table. It is optional, so let's not give it. We can just go on next and we can create our crawler. As of now, our tables are not populated. So we have to first run the crawler. It will take some time to run the crawler. Let's wait for some time. Our crawler have run successfully, and now we can see that we have our new table that is created with the name data warehouse. So this is the use of crawler, that is, when you run a crawler on specific directory in S3, it will automatically create a table out of it, and it will automatically learn the schema of the table. So when you go inside a table, we can see that followers, track ID, artist populated, everything is populated automatically. And if you want, we can edit the schema of this and we can convert the string into integer or whatever is our choice. So we can do that. Okay, so we can see the details of this. We can see the input format is Parquet, output format is also MapReduce with Parquet. We have not partitioned our data anyway, so there is nothing available in the partitions, and we have not indexed as well. So yeah, this is the schema. Thank you. In our last video, we have created Glue crawler and we have created database and tables out of it. Now in this video, we are going to learn about AWS Athena. AWS Athena is an interactive query service that makes it easy to analyze data directly from S3 bucket using normal SQL-like query. So since our database and tables are already created using AWS Glue, now we can make use of Athena to write a simple query on top of the database that we have created. So now let's move ahead to AWS Athena. So this was the crawler that we have created and the table we have created. Now if we go to Athena, we'll see this page. Now we can just go and click on Launch Notebook Editor. Now we can see that a default data source is data catalog and database is selected as Spotify. Now we can see our table as Spotify data warehouse. Now if I just write select star from data warehouse limit 10, right? Now to run this query, first of all we need to do some settings. Now we have to create a S3 bucket that will save all the queries that we have done in Athena. Now first you have to go to S3 and we have to create a bucket called, let's say, Athena output Spotify project. Now I can create a bucket. Now I can go back to my Athena, I can browse and I can choose this. Now I can just go and hit save. Now if I go back to my editor, I can see that there is a run option here. Now if I just run the query, I can see the output. So now it's very simple for us to do any sort of analysis by using normal SQL-like query. I can just write select name track ID. It also provides with lots of hint. Now whatever we are querying, if we are going to S3, we can see that there is a folder that have automatically populated, and we can see, we just go and see we can see the output has been populated in this S3 bucket. So this is how it works. Thank you. In our last video, we have created a glue crawler and we have created database tables out of it. Using Athena, it was very easy for us to analyze the data using normal SQL-like queries. Now, in this video, we'll see how business analyst people can make use of AWS QuickSight to create visualization out of the data that is present in S3. This is not a data visualization course, hence will not be going too much deep into data visualization. I will just tell how we can connect QuickSight and make use of Athena-like query to create a visualization. So let's move to AWS console. I can just search for QuickSight. So this is the first time I am landing to QuickSight, so I have to sign up for QuickSight. So for this project, we can just take an enterprise edition which is free for 30 days. So the location I have to take is Mumbai. Now I have to provide a unique account name. We don't need a AWS Redshift and RDS. I can just click on finish. I have to go back and provide an email. Now it is creating a QuickSight account for us. It is taking some time to create an account. Once the account is created, I will resume the video. Now our account is created and we have landed in this page. We can see that there is a dashboard, there is an analysis and there is a dataset option. First, we have to create a dataset. I can just create a new dataset. I can just go to Athena. And our data source, as of now, let's just write create a data source. Or we have to select a work group from here. Let's say data one. Now let's say I want to use this table. I can select. Now I can just create and visualize. So now I can see that we have all the fields which are populated here. Now I can easily create visualization using this. Now we have connected QuickSight to the Athena and we have got a data in a QuickSight. Now we can make use of the data that is present and create a visualization out of it. And we can hit on publish to show it to the customer once the visualization is ready. Thank you.